This is just to look at the unit review. So my encouragement is go through that unit review sheet yourself first. Try it out yourself, see what you can come up with, see what you remember without having to look things up. Then, after you've struggled with it, and it's okay to struggle, it's in fact good to struggle, really helps to build those brain powers. But yeah, after you've done that, then go through this video, go through the filled in note, and then confirm what you've done and see what you didn't remember, and hopefully you'll be able to learn the rest of the material that way. All right, so let's go through just unit piece by piece. So we've started with looking at functions versus relations. So in order for a relation to be a function, we have to make sure that each x value corresponds with only one y value. That's the key thing, and we saw that was particularly true with what we called the vertical line test, where if you draw a vertical line, it can cross a function only, well, once. And if it crosses twice, well, that's not a function. So something like a circle. If I were to draw that like that, well, if I were to draw a vertical line, let's say here, it crosses twice, therefore not a function, just a relation. Whereas if I were to draw something like this, you can have all sorts of movement, let's say, in your graph, but as long as wherever you draw a vertical line, it's not crossing twice, that would be a function. Okay. Then we moved on to notation with this. So in the notation, we have this f of x, and again, the f could be a number of different letters. We just use f as the starting one because, well, for function. Represents the name, well, of the function. And x represents the value of the, in this case, we'll just say the independent variable, or the input. If you put in something along those lines, that's all that matters. So the thing that you're inputting. And it only works well with a function. Okay, so if you have these, what we saw is that basically whatever x is, whenever you have something else in the brackets, you're just replacing x with what's in the brackets. So if we have f of 1, well, we have now 1 squared minus 2 times 1, because that's 2x is 2 times 1 plus 1. And then just calculate it out. So 1 minus 2 plus 1 is just 0. F of negative 3 plus g of 1. So just separately plug into f and g. So f of negative 3 would be negative 3 squared minus 2 times negative 3 plus 1. So that is that f of negative 3. And then g of 1 is just going to be this next section, which is going to be, well, just 1 plus 2. Calculate those out, put it all together, you have your answer. So it's going to be 9 plus 6, careful of the double negatives, plus 1 plus 1 plus 2, which is 15 plus, well, 16, 17, 19. All right, and this one looks a little different. F, and then there's a g of 4. But all it's saying is, well, for the function f, plug in this g of 4. But g of 4, that's something we can calculate. So let's calculate what g of 4 is, get an answer for that. And then what it's actually asking for is, we'll take that answer and plug it into your next function. So it's in a function inside a function. A little different, maybe a little odd feeling, but we're still using the same ideas as before. Inputting, getting answers, but we're just doing it twice. So we're going to get 4 squared minus 2 times 4 plus 1. So let's just see what we get for that. 16 minus 8 plus 1 is 9. Okay, so what I just said there is g of 4 is equal to 9. So what this is actually asking for is, we'll replace g of 4 with what we just found out to be 9. Which is then just, no, well, I messed that up. I switched the functions around. So let's just quickly change that around. G of 4 is just 4 plus 2. So even easier. It's just 6. And so then plug in 6 into there, replacing G of 4. And now we'll take that 6 and plug it into f of x. So 6 squared minus 2 times 6 plus 1. 36 minus 12 is 24, plus 1 is 25. And there we have it. That is the answer to f of g of 4. Okay, and we also saw graphs with function notation. Remember, all that it means is that the thing inside your function notation, that is your x. And so then what the function notation is asking for essentially is what is the y value? So if we're looking at -3, we're looking at, well, where's -3 on the graph? That's the point -3, -2. So the corresponding y value is -2, so f of -3 is -2. So that's the one thing I find that is easiest to forget. All this function notation is, in the end, just like x's and y's. They are points that we can put on a graph. We just have to remember that the y coordinate is just the value of the function f of x. Okay, determine the value of x such that f of x equals to 2, or you can think of this as where is y equal to 2. So go to 2 on your graph vertically, because it's your y value. And that matches up with x equal to 4. So that is 4, 2 there. So x equals 4. That will imply, that's what the arrow is there, implies f of 4 is equal to 2. Okay. Then, it's a little, let's just erase that. It's a little messy there. Let's just rewrite that in terms of our notation here. So x is an element of real numbers, how we typically started, and then we may have had some sort of interval a to b. And so that is the notation. So that's what you can include in the blank there. And we had a number of different ways of figuring out the domain and the range. And if you had range, you just use y's instead of x's, or whatever variable you have in your particular situation. But yeah, how we figure out what the domain and the range are is we could use an actual graph. If we have the given graph, just look at what x values are covered, what y values are covered. Or if it's a function, maybe you can picture the graph depending on the kind of function it is. If it's discrete, then just look at the actual points, the actual numbers in the data table, and just list your x and your y's. And the other way we looked at was, well, what can't x be? So some functions you can't plug things in, whether it's like a square root. So square root, you can't have negatives. And a rational, that's the fraction one, you can't divide by 0. So we had those situations where we just had to be careful about things that you can't plug in. And that's another good way to figure out the domain. So let's actually go ahead and do that with some of these. So for the first one, you have 3 times x minus 2 squared plus 7. It's just a quadratic. So keep in mind, quadratic's just a parabola. So let's just picture it, whether you want to draw the full graph or just a quick sketch. We just need to know where is the vertex. Well, the vertex would be 2, 7, because it's in vertex form there. So 2, 7. And then you just need to know, is it going up or down? Well, in this case, because it's positive, the lead coefficient, it's going up. Which means we have a minimum. So that's going to help us with the range. The domain is always x is an element of the real numbers for parabolas. Another way of thinking about this is, it's a function. Could you plug anything into this equation for x? Well, yeah, you could plug in 5, you could plug in 22, you could plug in -1,000. You will always get an answer. There is nothing that could go wrong, so the domain is, well, any number. It's in those situations with square roots, fractions, that's where things go wrong, and that's where we have to be careful in terms of the domain. For the range, y could be any real number such that, well, now we keep in mind that rough sketch or that mental diagram you have. It's a parabola, has a vertex of 2, 7. That means we're reaching a lowest point of 7, so y is going to be anything bigger than or equal to 7 itself. Okay, so let's look at that. Let's take a look at this rational function, this fraction. So we want just the domain. We'll worry about the range in the future unit. But for the domain, we just need to think about, well, if you're dividing, what can you not divide by? Or when would that be 0, the denominator? And that's where things will go wrong. And so we just can set that equal to 0 and figure out what this mystery number might be by rearranging and solving for x. And what you will get is x is equal to -1/2. So if x were -1/2, you would get 0 in the denominator. That would not be good. So for the domain, we basically want to not include that. That is our what we'd call restriction. So our domain will be equal to x is an element of the real numbers such that x cannot be equal to -1/2. Okay, let's continue. So the square root, we have to look at what's underneath the square root. We can't have negative numbers inside the square root. It needs to be greater than or equal to 0. So rearrange that, and what you get is x cannot be greater, or x is greater than or equal to -5. And so our domain would be any real number such that x is greater than or equal to -5. If you had -6, well, you get -6 plus 5. It was a negative number. If you had -2, which is greater than -5, well, -2 plus 5 is 3, which you can take the square root of. All right, and so that's the domain. I should write down domain here, just so you know that that's it. And for the last one here, we have a graph. If you have a graph, for the domain, just look horizontally, so left to right. Where do we start? We start there. Where do we end? We end at the right side there. And so our domain is just going to take that into account. And we cover everything in between. The graph doesn't have any gaps, so we need to take that into account. So we start at -5, but it's open. So we aren't including -5. And then we reach all the way to 1, which is filled in. So we can say it's less than or equal to 1. And that would be the range. Or that would be the domain. For the range would be equal to, well, we just need to now look vertically. What's the smallest? It's a kind of like a semicircle here. There's a smallest value there. We're going to say it reaches -3. So we'll start writing that down. So y could be any real number, and then let's write down the particular interval it's in. So it's starting at -3. That's the smallest. We always like to go from least to greatest. That's y. And then we want to see, well, what is the greatest? Well, the greatest value is, it gets up to 1. It does that on the left and the right side. The left side is open, but the right side is filled in. So it does actually reach that y value of 1. So I can say it's less than or equal to 1. And there we have it. That is the domain and the range. So that's just kind of a quick review sheet, just a quick snippet of each lesson from the unit. This isn't going to happen for each unit, but it's a good way to review just in general, is go through each of your lessons and just do a quick summary of the lesson. Write down the key points for yourself, and then use that to begin kind of, in a sense, building like a summary sheet of the unit. In this case, this is like 1 page front and back for yourself. And it's a good place to begin your studies and to begin consolidating what you know and what you need to work on within the units.